Hi guys, this is a quick tutorial video. I was asked to help clarify some questions from the 5.3 and 5.4 homework. And so I'm doing 5 questions by request. Questions 4 and 5 from 5.3 and 8, 9, 11 from 5.4. I also did make a video for someone else, question 13 from 5.3. So if that one was a problem for you, you can request that one as well. That one I'm not including here though. So if you want, you can just send me a request. I know the homework was already past due, but if you were unable to finish it because you're confused or because of any other, personal reason, that's fine too. Just let me know, send me email, and I can reopen that for you to finish. Or if there's something that you want to catch up on that you maybe missed earlier in the semester, you can let me know too. Okay, so anyways, without further ado, let's get into this. Question number 4 from 5.3. It says find the indicated z-scores shown in the graph. So look here, they give you a normal distribution, right? It's a normal table. They give you the table to check, but we're not using the table. We're just gonna use our good old faithful Google Sheets. So I'm gonna go to normal distribution since I'm looking for z-scores. Make sure your mu is set to 0, sigma is set to 1 because that's the standard mean and standard deviation. If I'm talking about z-scores, right? It's normalized to 0 and 1. And then there's a couple ways you could do this. So here I'm given 0.4686, but if you think about it, I'm trying to find this z-score, right? If you want to convert this to a percentile, you take this area, which is 0.4686, and add it to everything on the left, which is zero point 0.5. So that'll give you 0.9686. And where does that go? That goes in the bottom half of the page because that's where I input probabilities, right? So this would be 0.9686 there. And then I have the z-score. It says x, but in the case that mu is 0 and sigma is 1, this x is actually a z-score. Okay, that's one option. The other option is to figure out the probability that's, in this whole shaded region instead. And half of it would be 0.4686, right? But here I want double that. So here's a little trick. You could do a separate calculation, double it in like a Desmos calculator. But here's a little trick within the same Google Sheet. Hit equals first and put 0.4686 times 2. Right? And that would be 0.9372. That's the sum of these two shaded regions. And notice my z-score is the same either way I go about it, right? 1.8606. Okay, now answering the questions, z equals 1.8606, right? But the way they phrased it, they're asking you for both of them. So they want the negative and the positive and separated by commas, round to two decimal places. So that'll be negative 1.86 and comma positive 1.86. All right, let's check if we're correct. Yes, we are. All right, next question. Next question was question 5. Okay, so this time, similar question. So I think it's actually easier. Here we're given the right tail. So I can go straight down to looking over here. This is the right tail, right? And just input that number, 0.0274. And right here I got a z-score of 1.9205. So right there it is, right? If you want to think of that in terms of percentiles, it'll be 100 minus 1 minus this. So I could do that here equivalently, right? I could do equals to 1 minus 0.0274, which is 0.9726. That's the percentile over there. And notice I get the same z-score. Yeah. Okay, if for completing this one, we do it 3 ways. Let's do it over here too. So let's say I wanted to know what is this region in the middle. That's 100% minus these two little tails, right? So I could think of that as equal to 1 minus 0.0274 minus another 0.0274. I get 0.9452. That's this white region in the middle. And again, see the z-score is the same in all 3 cases. Okay, so what are my z-scores? I got two, one negative, negative 1.92, and positive 1.92. All right, let's check if we're correct. And yes, we are. Okay, that takes care of the requested questions from 5.3. So now let's go to 5.4. Wait, was that 5.4? Okay, thought I did 5.4 for a second. Okay, good thing. Okay, let's preview this thing. And we're asked to do questions 8, 9, and 11 here. So let's start with number 8. All right, so population mean and standard deviation given below. Find the indicated probability to determine whether, okay, for sure, trying to find probability that this time that indicates I'm probably in the top, I'm thinking. Find the indicated probability, determine whether the given sample mean would be considered unusual. Okay, sample size n equal to 40. Find the probability of a sample mean being less than 12,750 or greater than 12,753 when mu is equal to 12,750 and sigma is equal to 2.3. So first, right off the bat, I notice I've got this sigma and this mu, right? So it says sigma, which means I'm talking about a normal distribution as opposed to a t distribution. Actually, we haven't. Did we talk about t distributions? Yeah, I don't think we got there yet. So anyway, I'm in a normal distribution, right? I'm gonna fill in my mu as 12,750 and my sigma as 2.3 here. Okay, and I want to know what's the probability of being greater, oh, sorry, less than 12,750. Let's do that first. So 12,750. The probability of being less than that. Did I write that right now? Yeah, okay. Oh, that's actually exactly the mean, right? Exactly the mean. So that's exactly 0.5. So hold on to that number. 0.5 is half the story. In fact, let me write that down here in a calculator. 0.5 is half the story, right? Or greater than 12,753. So that's the other number I'm going to put, 12,753. I'm looking for the probability of being greater. That's this guy right here, right? Probability of being greater than that next. It's 0.096058. So plus, because it's or 0.09, what was it? 6058. Okay, so altogether that sums to 0.596058. And it sets around to four decimal places, so that would be 0.5961. All right, let's check. I'm sorry, I'm sorry, guys. I totally forgot. Okay, so this right here, what I did. Okay, it's a good thing I made this mistake. So this is a good thing to um to avoid. Sorry, guys. I totally was ignoring the question. This is the sample size n equal to 40. I'm finding the probability of the sample mean being that. So I have to change something here. I'm not dealing with the original sigma. I'm dealing with that sigma divided by the square root of 40 here. Sorry, I forgot that step. Critical step, because this is gonna, the probability of a sample mean being whatever it is much less than the original, right? Much less than the actual original values. Okay, so let's go to the same values. The original one was 12,750. Notice that it's still 50% though, because that's still exactly the mean. And then for the other one though, the if I put in 12,753, notice the probability is so tiny that to the nearest 1, 2, 3, 4, 5, 6 decimal places, it's actually zero. It's actually zero. So it's very, very unlikely that you're greater than 12,753 for that sample mean. But the probability of being less than 12,750 is 0.5. So when I add them together, it's actually 0.5 plus 0.0000, which is still 0.5. Okay, so let's check now. Okay, there we go. There you go. Yeah, so sorry about that mistake, guys, but actually I'm gonna leave that mistake and not correct it in this video because I think that's something good to indicate and learn from. That's a good mistake to be cautious of. Okay, would the given sample mean be considered unusual? Okay, no, it's not unusual to be less than 12,750 or greater than 12,753 because zero point 0.5 is a large probability. It's bigger than 0.05, right? So not unusual because it's greater than 0.05. So that's one. Okay, and so next question we're asked to do is number 9 and then number 11. Yes, here's number 9. Heights of fully grown trees, specific region, normally distributed, mean of 58.5. So I'm going to put that mean in, 58.5. Standard deviation of 7. And okay, let's answer the question. Random sample size 19. Okay. Central limit theorem, find the mean standard. Okay, blah, blah, blah. Okay, so first of all, mean of sampling distribution, that remains the same as the original mean, right? Mean is unchanged. Mu sub x bar is still 58.5. What about the standard error? So that's sigma sub x bar. That's gonna be where you input this equal to 7, divide by the square root of the sample size, which in this case is 19. Oh, I think a bad syntax here. I think this is a parentheses here. Yeah, okay. Or if you don't like that, you can do the decimals too. It's 7 divided by square root of 19, same thing. 1.6059. To the nearest two decimal places, 1.61. Let's check. Okay, good so far. Oh, wait. Okay, yeah. Choose the correct graph of sampling distribution. Sampling distribution has a sigma of 1.61. So the center should be that 58, right? Not it should not be this one. This is the z-score distribution. I want 58.5 to be in the middle. My standard deviation should be only 1.6 though. So this one, if I look, is way off because here, look, two standard deviations at 44. That's using the original standard deviation of 7, right? It should only be a couple, like about 3 off, and that's about here. So that's B. Letter B is the answer I'm looking for. Can't fit it here. There you go. Okay, that's correct. Oh, was that it? Oh, that was it. That was it. Okay. So question 11 now. Okay, height of woman, ages 20 to 29, normally distributed, mean of 63.9, assume sigma is 2.7. Are you more likely to randomly select one woman with a height less than 65.3, or are you more likely to select a sample of 17 women with height less than 65.3? Okay, I can answer that right away. Um, because without even calculating. So, are you more likely to select one random woman with a height that is this less than, is this less than average? 65.3? Um, no, that's 65.3 is above average, right? Because the mean was 63 here. So let me just put it here. 63.9. And then and I'm looking for a height that's less than 65.3. So it's very high probability that the sample mean would be less than 65.3 because that's like way out there in terms of standard deviations. When you take a sample mean standard deviation, it shrinks the standard deviation, right? So the 65.3 would be way high. So it's very probable that a sample mean is going to be below that high value. So that's much more probable for the sample mean. Okay, but let's answer the question. They're going to direct us through the steps to actually compare the numbers. But let me go ahead and input my sigma here. And right here is for randomly selecting one woman. That's with the original sigma. So original sigma is 2.7, right? And the data value that I'm checking is 65.3. Okay, so here I'm looking at, let me just rearrange this windows a bit. Here I'm looking at what's the probability that its height is less. So I'm looking for less, right? Less is over there. P probability X is less than the value that was given. That's 0.6975 to the nearest four decimal places actually rounds up to 80, 0.6980. Okay, next one. Okay, what's the probability that the sample of 17 with a mean less than the same value? So this time I'm going to change my sigma from 2.7 to equals 2.7 divided by the square root of the sample size of 17. So notice my sigma just decreased, right? And the probability just increased to 0.9837. Okay, and okay. Are you more likely to select one? Are they much more likely to select a sample of 17 with me hit less than that? Because no, that's they're wording this wrong. It's not that one. Much more likely to select sample of 17 women mean height because the sample of 17 has a higher probability. Yeah, higher probability, more likely, right? That's obvious. Okay, that was it. That was it. All right, guys. So hope that helped. Maybe you already knew all that stuff, but even if you did, hopefully it'll be some helpful review to you. Okay, see you next time.